We're talking about agentic access today. We're going to talk about how OAuth is great to get you in there, but zero trust can keep you safe. Yep. Okay. So what we're going to cover is why zero trust matters for humans and agents. We're going to discuss how the model context protocol MCP works and its security best practices. And we're going to dig into zero trust plus OAuth and how it unlocks MCP. With Pomerium, where I work, it's all open source, and there'll be a live demo. So, is anybody familiar with zero trust here at all? Okay, cool. For those that aren't, here's like a kind of quick 30 seconds. So, it's a security model that assumes no implicit trust, not even inside your own network. So, like unlike a VPN where once you're in, you're assumed to be trusted. It's got per request authorization and authentication, and there's context-aware policies. So, not just your identity, but it can be devices, it can be sessions, it can be third-party data like on-call schedules, like PagerDuty or stuff like that. And it runs at the application layer, so layer 7 of the network stack. And other things it provides in terms of building blocks is strong identity verification, enforces least privilege, which is always a good thing in security. And there's always the continuous authentication and authorization. It's not just like once you log in, it's like literally every request. And you get your device posture and security verification. And it also has micro-segmentation, so this limits lateral movement in your internal network. And it's got the context-aware policy enforcement. And because it's a proxy, everything goes through there, so it's really great in terms of observability. You can pull in your OTel traces from there. And so this is kind of what it looks like in a nutshell. So typically you have a user that could be at an office, it could be remote, could be anywhere, it doesn't matter. And then you have the identity-aware proxy, and it's composed of a few things. So you have the proxy itself, which is where the requests go through. There's an identity provider, so think like GitHub, Google, Keycloak, whatever your work uses, Entra, etc. And then you have this policy engine. So the first time you go to access some internal resource, what happens is you're going to be redirected to the IDP to log in. Assuming you're logged in, you go to the next step where you're accessing some internal route through a publicly accessible URL, and the policy engine will determine if you have access to that or not. If you do, you're granted access for that current request, and then you get access to the proxy internal service or application. And that's kind of the flow, and it's literally like that every time. So in terms of latency, it's really negligible because the identity-aware proxy is installed at your network edge, so it's literally in your network. Nice things about that too is it's like we never see your data, so that's a good thing too. You can also air gap this because it's not a it's not a cloud-based solution. Cool. Just gonna take a sip of water here. I was running over here. So, I'm sure everybody's leveraged AI in some capacity, whether that's just trying out ChatGPT or maybe it's deeply embedded into your work now. But traditional systems assume like, a user login flow, think a login screen. But it's a lot different with agentic access now because maybe there's that initial login flow, but then you get you pass some information to some agent, and then that agent might go do stuff elsewhere. There's like a few things. It's hard to get some visibility there, but also it's no longer that normal login flow. And you kind of need a standard way to expose those tools securely. So let's talk about the model context protocol. And to be clear, we're not an AI company, so it's an identity-aware proxy in general. So it's like Kubernetes workloads, internal apps. It's just the model context protocol operates at layer 7, HTTP, so it just fits really well. People have coined it the kind of USB-C of, I don't know, agent access, but I don't know if that's such a good analogy because who knows? There's going to be another port type at some point. We're going to have dongles again, but I digress. That's what everybody's calling it, though. And there's clients and there's servers. Um, and then, MCP clients are stuff like Claude or like ChatGPT. There's open source ones like Goose from the people at Block, Visual Studio Code. You can make your own. And the other interesting thing too is an MCP server can also be a client that calls other MCP servers. And we're just going to talk a bit about the security best practices for model context protocol. And essentially, they added OAuth to their spec, I think a few months ago. Like to be clear, this spec is still pretty new. It came out in November 2024, so still pretty fresh, but it's been gaining a lot of adoption. And essentially, some of the security best practices are, like, one of the big ones is, put it behind a proxy, enforce authentication. You want to validate your tokens for the audiences and scopes, and you want to prevent token pass-through. And you also want to, preserve the user's consent when doing things, and you want to audit all access. And while the MCP security best practices don't explicitly say it, like, this just screams zero trust security to me. So although they've added OAuth to the spec, that's good. It's good to have security, obviously, but it can't enforce device trust or session-based policies. So, typically with OAuth, you'll have defined scopes, and so there's nothing really dynamic about that. So picture, like, I don't know, say you have like some MCP server that works with Google, so some kind of calendar booking. You maybe want people to be able to add events, but you don't want them to be able to delete the events because they're not you. So, like, you can set certain policies on certain tool calls, which is, I think, somewhat unique in what we're doing. Because right now you can secure an MCP server with policies, but nobody's really doing it at the actual tool call level. So you could, and a lot of these MCP servers, the way they work, it's kind of like gives you the keys to the kingdom. So it's kind of nice to give the keys to the kingdom, except for that one, and that one, kind of. So the policies from like a zero trust architecture really help with that. And yeah, and I kind of touched this on already, but you get your login through the identity provider, and that also gives you, like, that's that OAuth layer in terms of the MCP spec. But in my example about like the calendar app, for example, your agent needs to do the OAuth flow with Google. So, you're going to go through that OAuth flow. You're going to get a token back from Google. And typically what happens with the MCP clients is they'll receive those tokens. So they literally have the keys to the kingdom, your GitHub, your whatever. And it's not to say they're going to do something malicious, but it is the internet. So, the approach we've taken, and this is all open source I'm discussing, by the way. So there's a few things. In terms of DX, we handle the OAuth flow for you if you have an upstream service. So you still have to create the OAuth app. You can't get around that, but you don't have to actually implement OAuth in your MCP server. You just have to add some config to the route, and then we handle that whole flow. So that's a nice bit of DX. But the other thing that's nice from a security standpoint is when you get those tokens back from the upstream services like Google or GitHub, it never goes through the gateway. It never reaches the MCP client. We manage those tokens for you, and all that the MCP client gets is a short-lived token from us. So even if somebody stole that, it's short-lived, and the likelihood of them being able to do some damage is, like, I would say pretty low, versus, oh, the MCP client has your GitHub and your Google tokens, and for whatever reason the LLM did something with it, and now you're kind of screwed. So that's just another layer of security that I think is nice. And yeah, so like I said, OAuth, it's great that they've added it to the model context protocol spec, but it's not enough. You really need zero trust security in place, whether that's us or some other IAP. I think it just makes sense, especially if you look at their security practices that we walk through. And like the big thing is, it's like, OAuth says like, what can you do? But it's not, it can't say like, should you be doing this now, So anyways. Yeah. So I'm gonna do a time check here because I was a few minutes late here, but um, just kind of reiterating what we talked about here. So when with zero trust, you end up with a who, what, when, where, and why versus just you can do this thing. Um, the nice thing too about zero trust security in general, and this has nothing to do with MCPs, it's just general architecture, is uh, you know, it's really based on those policies. And like I can think of a concrete example where I have a jump box I use for demos and stuff, and like it's just on a DigitalOcean droplet, but I have to configure an IP so I can say, like, I'm at home, I can SSH into it. And then like I was at a coffee shop one day, I'm like, I can't access it because it's the wrong IP. And obviously I could add another IP, but then I'm exposing it to everybody. So we even support like native SSH with that. So everything I've talked about in terms of zero trust applies to SSH as well. And so you go through a regular login flow, except it's a device code instead. So anyways, but that's just zero trust in general. And yeah, we're open core, like I said. We obviously, like any company that's open source, there is enterprise version, but everything I've talked about so far and the rest of today is all open source. So yeah, so like I said briefly, for MCPs, we handle that upstream OAuth flow for you if you have that in place. There's no, the upstream tokens, like I said, are managed internally, and all the MCP clients get is that short-lived token. And the identity policies are always enforced. And I'm not sure where my screen just changed, but let's close that. Okay, am I logged in here? Okay, so let's just take a quick peek here. I'm just gonna SSH in here. So this is actually a proxy route through SSH. So it is a native SSH call. There's no client or anything, but I'm gonna log into my DigitalOcean droplet here, and we can just kind of see this, except I don't know how to type. Cool. Yes, edit anyway. I just a little context while I was a little late. I borked my config before I was coming here, so I was like trying to fix it, which I did. But so I'm not going to go through everything in here. This is a configuration for Pomerium in general, but the kind of key thing to look at here is the policies. So I'll zoom this in a bit so people can see. So here's my jump host, you can see here, and it's going to this internal route, and it's just got a route that's called jump, and so that's why if we come back to here, so this syntax here, it looks like, when I looked at this first, I was like, this isn't valid SSH to call. But actually the user is root at jump, which is actually a valid user, and we just use that to actually parse the route and apply the policies. So, but it's all standard. Cool. Let's see here. Where was I? Okay. So let's go to, like, for example, one of these here. So we can just kind of see how the policies are. So this one here, this is my development environment. So I have this route, which is publicly accessible. I can show you that after if you want, but it's basically like a chat app. And you can see here, for the demo, I have very basic policies, but these policies here just say only users with the email domain pomerium.com or nickit.co, which is my own domain. But these policies can be a lot more complex. You can put, certain times a day, device, like in terms of if you have some kind of registry at work, pretty much any third-party data, an API call and stuff. And I just want to show basically in terms of the MCP server configuration. So here we have this from route. For anybody that's been in the industry for a while, you're probably familiar with the Northwind database. It's just a test database. And anyways, we use this as our kind of like air quotes real sales data in terms of giving demos. But all you need to do to make this an MCP server is you just add this configuration in the YAML. There's more complex ones, like if you have the upstream OAuth in terms of like that calendar server I was talking about, you would have config in here as well, which would be for just the client ID, the secret, and the URLs for that OAuth app. But that's pretty much it. And yeah, let's see if we can go over here. Let's see here. I'll just skip through it. This I can't zoom in, but if we come back here, so you can see, like I was showing you before, the top route is the one that's the simplified one where there's no upstream OAuth. But in the bottom one, for example, you'd have your client ID, your secret, some scopes you'd define, and then basically your endpoints for OAuth. And that's kind of the gist of it. And I kind of want to show you, I ran into some issues getting set up this morning. So I am going to show you a short video, but this is a real thing. It's not me just talking vaporware. So where was it? Let's go in here. Okay. So I'm just going to kind of talk through this, and I might pause as we go. But essentially what we're looking at here is, this is a chat app I built. We use it internally at work. It's just using OpenAI's responses API. But what it's doing is I've selected a sales database, which is an MCP server. So we've secured that with the policies like I was showing you. And what we're doing here is we're saying, I want to get the sales numbers. We're actually pulling out something from Notion where we're asking to generate a sales report. But in that Notion document, it actually says, I'd like you to change the sales for France. So like basically cook the books. And so this is just going to show you how it actually stops it. So so it's just going along here, and you can see here, I don't know how much you can see that in terms of the size of it, but it says I need to update the sales numbers for France by multiplying them by 1.24, and so that's basically cooking the books there. And LLMs don't have morals. They're just like, they asked me to do something, I'm going to try and do it. So I'm just going to let this run for a second, and you'll see the key thing here in a second. So it's just reasoning in terms of like what the user wants to do. It's making some tool calls. It's trying to update the sales numbers here. So it says, okay, they asked me to update them by 1.24. So the interesting thing here is what I was talking about, where you can secure the MCP server or just internal routes in general. Here we're actually having a policy on the update tool, which actually allows you to edit the database. So for this particular user, which is me, I can read from the database, but I actually can't modify it. So I literally cannot cook the books. So this is going to run, and you can see it's running some SQL, and it's saying just change the unit price and multiply it by 1.24. Now, like I was saying with the identity-aware proxy, everything goes through it. So you have complete observability. You know who the user was, what the payload was. And so you can literally see on the right, okay, so it says this tool call was unauthorized, and it shows what it was trying to do. And basically, in the end, it still generates the sales report, but it wasn't able to cook the books. And I don't know, I think that's kind of neat. And this is something I think we're doing that's a little more unique, because the policy at the server level is great, but like being able to do fine grain and like laser focus on things, I don't know, I think it's pretty cool. Cool. That's essentially that demo here. Unfortunately, I couldn't show it live. Apologies, but I've been on a whirlwind travel tour. I got here at like 2 in the morning last night. So let's just go back to the slide deck. And yeah, so I basically covered these two things here, like the demo and stuff. So the key takeaways I want you to have are, like, I really think zero trust is mandatory at this point. Like, this came out of Google in the 2010s when there was a big security breach, and somebody got in on their VPN and just basically wreaked havoc. I can't remember the details of the breach, but they basically said, we got to do something about this. So they started these papers called the Beyond Corp papers, and from there they developed what's now called zero trust security model. And with that, the gateway, the identity-aware proxy is essential. It's not just a convenience. Like, you need this. Whether it's us or any other identity aware proxy, it's just something I think that's kind of table stakes this day in terms of security. And like I said, MCP and OAuth, it's great for security, adds a nice base, but the zero trust policies are really what makes it complete for your security posture. There's some resources. I imagine they'll be sharing the slide deck, and if anybody's curious to chat more, feel free to grab the QR code. But if not, thanks for listening to me ramble.